Grade 11 Algebraic Expressions, Surds and Exponents. Mathematics Paper 1 Algebraic Expressions, Surds and Exponents. We definitely expect questions on surds, on exponents, on algebraic expressions in Mathematics Paper 1, especially question number 2, just after the equations section. So let's have a look at some examples here from a past examination paper. Number 2.1.1, given that a is equal to the square root of 2x plus 1 divided by x squared minus 2x. And we want to find the value or values of x for which a is undefined. Now, as a general idea, an expression is undefined if the denominator is equal to 0. An expression is undefined if the denominator is equal to 0. So what it means is that to answer a question like this, we equate the denominator to 0 and solve for x. Our denominator in this expression is x squared minus 2x. So x squared minus 2x is equal to 0. It's a quadratic equation because x is squared. And if a quadratic equation has got two terms only, you can solve your equation by factorization. After factorization, we equate each factor to 0 to produce the results or the solutions that are required. So for this particular one, x is equal to 0 or x is equal to 2. So the idea is that for an expression to be undefined, the denominator must equal to 0. Therefore, to find the values of x for which an expression is undefined, you equate the denominator to 0 and solve for x. Number 2.1.2, an expression is non-real if the value inside the square root is negative. So to determine the answer that is required here, the expression inside the square root, in my case is 2x plus 1, must be less than 0. That means it must be negative. So you express that it's an inequality and solve that inequality to determine the value of x. So in this case, x is less than minus 1 over 2. If x is less than minus 1 over 2, this expression will become non-real. Then question number 2.2. We need to find the value of x. If f of x is equal to x squared minus 4 over x minus 2 and x is equal to the value given. This is such a big number. So reading this will be, this is 21,353,699,999. Okay, anyway, that's not important. The idea now we are using in this case is that we cannot use a calculator. The number is too big. Even if we put that in the calculator will express it in scientific notation because it is big. So we need to know how to simplify it. Now, if an expression is addition or subtraction, then think about factorization. So before we substitute the value of x that is given, we have to factorize this expression. The top one, x squared minus 4, is a difference of two squares. Therefore, it can be simplified into x minus 2 factor of x plus 2. Then we divide this by x minus 2. This factorization allows us to divide x minus 2 and x minus 2 such that the value of f of x is equal to x plus 2 in a simplified form. Now we know the value of x from the value that has been given in the question. So what we're going to do now is to do substitution. If we substitute x, then we can be able to simplify to get the answer that is required by the question. So the rest becomes a simple calculation that we have to do to answer the question. So I'm just trying to do substitution here. Right, in place of x, we're going to put the number that has been provided as the value of x, and then we add that to 2. If we add plus 2, then we have our answer for this question. So we basically, in this case, have been able to answer number 2.1. If an expression is given, for that expression to be undefined, the value of the denominator must equal to 0. If the denominator is equal to 0, then your expression becomes undefined. Then for non-real, we use the square root. The value inside the square root must be less than 0. It becomes an inequality that you must solve to find. Question number 2.3. Exponents, and surds. Number 2.3. Simplify the following expression without using a calculator. Now, what method do you need here? Please keep it in your mind. When doing maths and you are working through different examples and going through past examination papers, make it a priority that you are not putting all your attention to the answer, because the answer is not important. What is important is the thinking that informs the answer. Why are we doing things in the way we are doing? Why are we calculating it in the way we are calculating it? How do we solve the problem? The method is what you must make sure you understand. Understand the concepts that are being tested. So that is my question. For me to solve a problem like this, where there are big exponents and I am not even able to use a calculator, then your method must be factorization. Factorize the expression. Now look at the exponents given. The smallest exponent must be the common factor. So I have 2009, 2011, and 2007. So the smallest exponent is my common factor. So what we do now is that we're going to separate the top one into 10 to the power of 2007. That is my smallest exponent there. Then 2009 on top. If we subtract 2007, it will give us 2. So you will remain with, it will become 10 to the power 2. If you multiply 10 to the power 2007 times 10 to the power 2, you must get 10 to the power 2009. In my denominator, I do the same thing. 10 to the power 2011 will become 10 to the power 2007 multiplied by 10 to the power of 4. So 2011 minus 2007, we get 4. Then the next one is the square root of 10 to the power of 2007. Right, now I do factorization. So in the top part, we separate these two numbers into two different square roots. The square root of 10 to the power of 2007 multiplied by the square root of 10 to the power of 2. We put these two numbers under different square roots. Then at the bottom here, we also do the same thing. Write the square root of 10 to the power of 2007. Now we are doing factorization, therefore I'm going to put brackets here since there are two terms at the bottom part. So from these two numbers, 10 to the power 2007 and 10 to the power 4, I remain with the square root of 10 to the power 4 inside. Then from the second position, that is equal to 1. Then this allows me to divide 10 to the power 2007 divided by 10 to the power 2007. Then I remain with these numbers only to simplify. The square root of 10 squared, a square root and a square, they simplify each other, so that gives me 10. Then in my denominator, this exponent is 4. So if I work out square root, basically means exponent half. So the half which comes from the square root and this 4, they give me 10 to the power of 2. So this is 10 to the power 2 minus 1, which is equal to 100 minus 1. 100 minus 1 is equal to 99. So the answer to this question is equal to 99. 10 over 99. We can simplify this in short. I just made it longer to avoid confusion. But otherwise, the concept or the idea that we are using here is that if you are given big exponents, you can simplify your answer by using factorization. So if you look again, let's say, for example, the 10 to the power of 2011. So we splitted that number into the square root of 10 to the power of 2007 multiplied by 10 to the power of 4, all under one square root. Then from there, we separated the square roots into square root of 10 to the power 2007 multiplied by the square root of 10 to the power of 4. Then the first one, which is the 10 to the power 2007, this one cannot be simplified, so it stays like that. But this one here can be simplified to 10 squared. Then this 10 to the power 2007 is the one that we divided at the bottom and the top to remain with those two other numbers. So you must be able to do this. It comes from laws of exponents. The square root of AB is exactly the same as the square root of A multiplied by the square root of B. This is under the laws of exponents and sets. So the question number 2.3, the answer is 10 over 99, solved using the method of factorization.